Idea incubation is the fascinating process by which your brain works on a problem in the background, often leading to a sudden aha moment, that flash of insight when the solution seems to appear out of nowhere. At first glance, these breakthroughs feel almost magical, but cognitive science shows they often arise from a combination of preparation, unconscious processing, and the right environmental triggers. The process usually starts with immersion. You focus intensely on a problem, gathering information, trying possible solutions, and building mental connections. But when you reach a block, that frustrating point where nothing seems to work, stepping away can be surprisingly powerful. During periods of rest, distraction, or even sleep, the brain continues to process information unconsciously, making novel connections that might not happen under the pressure of direct effort. This is why Archimedes is said to have had his famous eureka moment while bathing, and why many people solve tricky problems while walking, showering, or drifting off to sleep. Neuroscience suggests that incubation taps into the brain's default mode network, a set of interconnected regions active during mind wandering. This network is excellent at integrating distant ideas, spotting hidden patterns, and reframing problems from new angles. Importantly, incubation isn't just doing nothing. It's primed by earlier focused work. Without that initial struggle, your unconscious mind has little to work with. The trigger for the aha often comes when the subconscious solution suddenly crosses the threshold into conscious awareness, sometimes prompted by an unrelated cue, a word you overhear, a visual pattern, or even a shift in mood. In laboratory studies, people who take short breaks or engage in unrelated creative activities often produce more original solutions than those who grind away continuously. Interestingly, positive emotional states can also increase the likelihood of insight, possibly because they broaden attentional scope and reduce fixation on failed approaches. From a practical standpoint, you can encourage idea incubation by alternating focused work with deliberate downtime. Walking, light exercise, engaging in a different creative task, or even meditating. Environments rich in diverse stimuli, like nature walks or art galleries, can provide the cognitive sparks that help unconscious solutions surface. And for complex multidisciplinary problems, like in nanotechnology or AI, exposure to ideas from unrelated fields can make those sudden connections even more likely. The real paradox is that the fastest way to a breakthrough often involves not trying to force it. By respecting your brain's need to wander and recombine ideas in the background, you open the door for those electrifying aha moments, which, while feeling spontaneous, are really the product of both hard work and hidden mental craftsmanship. An aha moment is a sudden realization that transforms a previously unsolved problem into a clear solution. It is distinct from gradual problem solving because it appears to happen instantly, even if the groundwork has been laid over time. Cognitive scientists describe it as a reorganization of mental representations that makes the answer obvious. This process often follows a period of impasse, where no apparent progress is being made. Brain studies indicate unique neural activation patterns during insight events. These moments are typically accompanied by strong feelings of certainty and satisfaction. Archimedes realized how to measure volume while bathing, leading to his famous "Eureka!" exclamation. It is like a camera lens suddenly snapping into perfect focus after being blurry. Incubation is a phase in problem solving where conscious effort is paused, yet the brain continues to work unconsciously. This phase allows mental processes to bypass fixation on ineffective strategies. During incubation, the brain reorganizes stored information, often forming novel associations. Cognitive psychology research shows that incubation improves problem-solving success rates. The length and type of incubation can influence its effectiveness. Returning to the problem after incubation can trigger a sudden leap to the solution. A composer solves a melody problem after a night's sleep without thinking about it directly. It is like bread dough quietly rising, even though nothing appears to be happening on the surface. Neuroscientific studies identify the right anterior temporal lobe as a critical region for integrating distant associations before an insight occurs. This area becomes active milliseconds before the solution enters conscious awareness. Gamma band brainwave bursts often precede an insight by a fraction of a second. The anterior cingulate cortex monitors conflict between current thinking and potential alternatives. Once a conflict is detected, it can prompt a cognitive shift toward the correct solution. This coordinated activity allows for the rapid reorganization that characterizes insight. EEG readings detect a spike in high-frequency activity just before a person announces the answer to a puzzle. It is like backstage workers quickly rearranging a theater set before the curtain opens. Unconscious processing enables the brain to explore multiple possibilities simultaneously without the constraints of focused attention. It allows for broader, more flexible connections between ideas. Relaxed states such as daydreaming or light physical activity often enhance this process. Without active suppression from the conscious mind, unconventional associations can emerge. This can lead to solutions that would not arise through deliberate, linear reasoning. The conscious mind only becomes aware of the solution after it has been prepared unconsciously. A poet suddenly thinks of the perfect line while cooking dinner. It is like a background computer program completing a complex task without interrupting the main screen. Fixation occurs when an individual is locked into a single, unproductive problem-solving strategy. This mental rigidity prevents consideration of alternative perspectives. Incubation helps break fixation by weakening the dominance of the unsuccessful approach. Changing the environment or switching tasks can disrupt entrenched thought patterns. New stimuli can trigger associations that were inaccessible under fixation. This creates the conditions for an insight to occur. An engineer resolves a design problem after spending the weekend hiking. It is like shaking a snow globe so that the settled pattern of flakes is completely rearranged. Insight moments often produce an emotional high, which reinforces the memory of the solution. Neurochemical changes, such as dopamine release, accompany this event. The positive feelings can encourage further creative exploration. Emotional arousal can also improve recall of the problem-solving process. The joy of insight increases motivation to continue working on related challenges. This interplay of emotion and cognition helps sustain creative momentum. Solving a particularly tricky crossword clue brings a rush of excitement and pride. It is like catching a sudden gust of wind that propels a sailboat forward faster than expected. Many insights arise from combining previously unrelated ideas into a new, coherent whole. This process depends on a broad base of knowledge and varied life experiences. Cross-disciplinary exposure increases the probability of such novel connections. The recombination can solve problems in ways that would not emerge within a single domain. These idea mergers are central to the creative process. They often lead to practical innovations and conceptual breakthroughs. Velcro was invented by studying how burrs stuck to clothing and applying the principle to fasteners. It is like mixing two colors of paint to create a completely new shade. Environments that allow a mix of intense focus and relaxation are most conducive to insight. Psychological safety encourages experimentation with unconventional ideas. Novel experiences stimulate the formation of new mental connections. Restorative activities, including meditation and sleep, facilitate unconscious problem solving. Time constraints can sometimes promote creativity by forcing unconventional approaches. A balanced environment supports both the preparation and incubation phases. Some tech companies design workspaces with both collaborative areas and quiet relaxation zones. It is like giving a plant both sunlight for growth and water for renewal. Understanding the mechanisms behind insight can improve problem-solving strategies. Deliberately incorporating breaks into work schedules can boost creativity. Alternating between different types of tasks refreshes the mind. Bringing together individuals with diverse backgrounds enhances idea diversity. Trusting the process of unconscious incubation allows solutions to surface naturally. Applying these principles can increase the frequency of aha moments in both individuals and teams. A design team alternates brainstorming sessions with outdoor walks to encourage breakthroughs. It is like casting a fishing line and patiently waiting until the right fish bites.